Okay, these are the 8.3 notes, inverse trigonometric functions. This is page 2. So we are going to talk about how we develop the graph for inverse sine. We are going to start by cranking out the values for sine. And I am going to label my graph here. Could have done that before you started watching. Okay. If you're comfortable with this, great. You should be able to crank out these values. If not, the unit circle is below. Negative pi just means we are going clockwise around the unit circle and not counterclockwise, but the sign at negative pi is 0. Sign at negative pi over 2 is negative 1. At 0, we've got 0. Pi over 2 is a 1, and at pi, the sign is 0. So when we go to graph this, I have got this one period of our sine curve. Keep in mind this repeats indefinitely both sides. Right now we are just looking at the one period. The points we used to graph were negative pi 0, negative pi over 2, negative 1, 0, 0, pi over 2, positive 1, and pi 0. So if I am going to graph the inverse, I'm going to flip those points around. I got 0, negative pi, negative 1, negative pi over 2, 0, 0, 1 pi over 2, and we talked about this in the inverse function notes. We can just flip things around. So now I am counting by pi's on my y-axis. And by units on my x. Okay, so let's graph 0, negative pi over 2, 0, negative pi, negative 1, negative pi over 2, 0, 0, 1 pi over 2, and 0 pi. And as I go to sketch this out, I realize I have a problem, because even this one period does not pass the vertical line test. This is not a function. So, not a function, because 0 gives me negative pi, gives me 0, and gives me positive pi. We are going to fix this by restricting the range. In the past, we've restricted domain a lot. Here, what I want to do is restrict the range so that I don't get those repeat answers. Okay. So my domain of inverse sine is negative 1 to 1, which makes sense. Those are the acceptable outputs for sine. The range, though, is going to go from negative pi over 2, keep in mind we're talking about the range now, to pi over 2. After that, our values start repeating, which means in degrees, our range is going from negative 90 to 90. Keep in mind, that is giving me two quadrants that are connected. Okay. And so we are clear. There are two ways you're going to see this: inverse sine and arc sine. Those mean the same thing. Okay. So now let's take a look at that unit circle as we consider cosine. Okay. First off, if we talk about cosine, cosine is positive in quadrant 1, but it's also positive in quadrant 4, so that doesn't help. I cannot use negative pi over 2 to pi over 2. Those are going to repeat output values. Okay. Cosine, though, is negative in quadrant 2. Sorry, quadrant 1, quadrant 4. Did I just say 2 twice? So sine is defined in quadrant 1 and quadrant 4. Inverse cosine is defined in quadrant 1 and quadrant 2. So here are my positive values of cosine. Here are my negative values of cosine. Okay. So that's in yellow. When we talk about tangent, okay, tangent is going to follow the sine. So let us get, I don't have a brand new color. Let's go with a green here. My tangent is going to be positive in quadrant 1 and negative in quadrant 4. Notice here, though, we do not include the endpoints for tangent, because at those endpoints, we actually get values that are undefined. So the tangent is going to follow our sine, other than we do not include those endpoints.